Hi, it's Mr. Kender, and we're looking at finding a table of values for a quadratic function. It's always something you're asked in all parts of graphing, is to fill in and plot from a table of values. So, we have a quadratic function, y equals f of x. The f just says function, the x means evaluate at this point. So sometimes it'll be, okay, I want to find where the function has an x value of 2. And so you just substitute in 2 into everywhere. So, and we must plot the points to approximate a parabola. So it's a U or N shape. Okay, so when we actually start going, you'll get this U or an N shape. So you have a maximum or a minimum value as our turning points, things we've kind of touched on in the last video. So example 1, find the table of values for the function y equals x squared minus 2x plus 1 for the integer values negative 2 is less than or equal to x is less than or equal to 2. Whew, lots of information there, but let's try and pick it out, getting rid of some information. So first, step 1, create a table of x and y values. So when you represent them this way, I always put x first, then y, because that's the way I read it. Plus, I need to find the corresponding y values. So x values, well, we're told it's between negative 2 and 2. It's integer values, so that means negative 2, negative 1, 0, 1, 2. So integer values are just those values on a number line, right? Like on a whole number line. So we have done that, and we can't go any further with our y values, right? So at this point is the part that most people get stuck on. How do I continue? So that means each of these is going to be a different problem almost that we have to do. And don't worry, because they're actually not that hard of problems. It's just we have to substitute x equals negative 2 into this original function up here with the dot. So let's do the first one. So here, this is why they sometimes say, let's say it as f of x, because we can say that as f at negative 2, and that tells me everywhere I see an x in the original, I'm going to put negative 2, because that's that x squared. Then I'm minus 2, because that's already there. Then I'm timesing it, though, by negative 2, because that's what I substituted in for that x. And then plus 1. So here, I'm going to get 4 plus 4 plus 1. So I can substitute in my 9. Similarly, I'll do the next one in red over here. So we have f at negative 1. So that means I'm just looking back up here. I'm just putting in negative 1 for that x. Then I have to square it. Then I have minus 2. That's times by negative 1. And then plus 1. So if I kind of start getting rid of stuff, negative 1 squared, well, negative 1 times negative 1 is positive 1. Negative 2 times negative 1 is positive 2. And then this is plus 1. So I get a value of 4, where x is negative 1. Next, I have f at 0, so our function at 0. So that means I have 0 squared minus 2 times by 0, and then plus 1. Well, we can really easily see that 0 squared is 0. Negative 2 times by 0 is 0, and so we're just left with 1. Okay, I'm going to scroll down a little bit so I have a little bit more room, and let's look at where it's 1. Okay, so I'll do this in black over here. So I'm going to evaluate f, our function, at 1. So here, we're going to have 1 squared minus 2 times by 1, and then plus 1. So here, 1 squared is just 1. Minus 2 times 1 is minus 2. And then we have add 1, which gives us a value of 0. 1 minus 2 is negative 1, and then plus 1 is 0. Last one, I'm going to resort back to going in blue. Or actually, I'm going to do this one in green. So I'm going to divide f at 2. So we're going to plug that in. So we have 2 squared minus 2 times by 2 plus 1. So 2 squared is 4. Minus 2 times 2 is minus 4. So that first chunk is 0. And then we add on 1. So our value will be 1. And that's why I chose the last second to change it to green, because I could see what it was going to be. So notice, do our values kind of switch around it? Our values turn around. That looks like 0. We're not asking for that right now, but just to kind of show you. That's where we're going to take this. So that's if you do it non-graphically. So next, we're going to do this for x squared plus 2x minus 1 for these values. So that means I'm going to do f at -2, f at -1. I really hope I leave myself enough room. For you, I would recommend leaving a few lines, giving yourself as much room as possible. When you first start out, this can take quite a bit of room. So I'm just going to start substituting numbers in, so you can kind of see when they're in a line that I'm doing the exact same every time. I'm just changing this one number. So here I'm getting -2. Make sure you put the brackets, put them in brackets when you square stuff, just because when we start running with this, if you don't put it in brackets, your calculator will change your answer if you're using your calculator. So notice how I did that first term all the way down. It was just that x squared term. Next, I'm doing this. The next thing that's all the same way is all of them are plus. So next, it's 2 and then times by, and then we have this x. So our x, well, this is where we change this for each one. So -2, -1, 0, 1, 2. And then I'm going to put this whole thing in there in brackets, just because I'll know I want to calculate that. I just don't want to get messed up with this last -1 at the end. I don't want to make myself an escape or a mistake. So sometimes it's helpful just to put brackets so you don't make mistakes, right? So here, that means I'm going to get, let's just solve these out. I don't have that much room, so I'm going to do -2 times -2 is 4. So this is 4. And then this is -4. So 4 minus 4 is 0. This is -1. So here, this is 1. This is -2. -1. So here, I have 1 minus 2 is -1. So this is -2. So as I'm doing this, I might as well fill it over here. Same time. Here, 0, 0. So 0, 0, -1. So this should be -1 as well. So it kind of looks like we've already hit our turning point. Then we have 1, 2, and -1. So the 1 and -1 on the ends will cancel out. I'll be left with a 2 here. And lastly, this will be 4. This will be 4. And this will be -1. So 4 and 4 is 8. And -1 is 7. Last one we're going to do is find the table of values for this function. So same thing. Let's write it out in terms of functions. So f it, because I like it because it actually shows what you're evaluating each time instead of just putting it in the format of y equals. That is why it's nice of just writing f at. Because I know personally, if I go back after I've done a bunch of work, I don't always remember exactly what I've done until I gaze it over for a while. So even if you turn your head away for a second, this can help keep yourself on track. So here we're going to get, I'm just going to square them as I go. So this is going to get me 4, 1, 0, 1, 4. So as you notice, sometimes once you start doing this a bit, you start to pick up, oh, that's your perfect squares. Then we have minus, 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 and then it's minus, x. So this is actually going to become minus, minus. This would be a minus, minus makes a plus. This is 0, so this doesn't matter. This would be, well, it'll be minus 1 and minus 2. And then lastly, plus 3. So I'm kind of doing a little bit of maths in my head as I'm going. You don't have to, but I'm also showing you what would be adequate if you wanted to write that down. So first one, 4 plus 2. 4 plus 2 is 6. Not 7. Is 6 plus 3 is 9. Then we have 1 and 1, and 3 is 5. Then we just have 3. Then we have 1 minus 1 is 0. We have 3. And lastly, 4 minus 2 is 2 plus 3 equals 5. So it'll go 9, 5, 5. 9, 5, 3, 3, 5. So notice we don't really have one turning point. So that means the turning point will be in between here. So not in between our 3 and our 3, because that doesn't make sense. In between our 0 and our 1. So our turning point would probably be at 0.5.